Astronomers at the Keck Observatory have made a major discovery. A massive galaxy cluster, RXC J0032.1+1808, is undergoing a dramatic merging event. Galaxy clusters are vast cosmic structures containing up to thousands of galaxies, all bound together by gravity. They are perfect laboratories for studying galaxy evolution and cosmology, forming from smaller mergers and growing by accreting subclusters. Studying merging clusters, in particular, helps us understand shock physics, cosmic ray acceleration, and the self-interaction properties of dark matter. The focus of this study is RXC J0032.1+1808, a rich galaxy cluster at a high redshift. This cluster was first identified at visible wavelengths way back in 1965 under the designation ZWCL 0029.5+1750. It's a massive cluster, with an estimated mass of about 1.1 quadrillion times the mass of our Sun. A team of astronomers, led by David Whitman, decided to take a closer look using the powerful Keck Observatory. They specifically utilized the Deep Imaging Multi-Object Spectrograph, or DEMOS, to gather detailed data. The team was led by David Whitman from the University of California, Davis. Their observations confirmed that RXC J0032.1+1808 is indeed in the process of a major merging event. The key evidence was the cluster's bimodal X-ray morphology, showing two distinct peaks, unlike the single structure seen in optical maps. These two distinct peaks are separated by approximately 1.3 million light-years, strongly indicating a cluster collision. The astronomers also managed to gain more insights into the properties and timeline of this cosmic collision. The data, combined with previous radio observations, suggests the cluster is seen after the first pericenter, meaning it's post-collision. The team estimates that this major merger occurred between 395 and 560 million years ago. The low line-of-sight relative velocity of about 76 kilometers per second suggests the merger is not head-on, but is primarily occurring in the plane of the sky. In conclusion, RXC J0032.1+1808 is a rich, bimodal merger, making it an excellent laboratory for further studies into the physics of merging clusters and dark matter behavior.